Hey guys, so we're back, and yes, this is the unit circle again, okay? This time we're going to be dealing with sum and difference identities, okay? So the first one is the sum and difference for cosine, okay? This is alpha, and that one is beta, okay? These are just, again, terms for measurement like theta or t. Okay, they're all just they're terms of measure. Okay, so we have cosine, right? If we have the cosine of alpha plus beta, we're going to be using this formula. And if we have the cosine of alpha minus beta, we're going to be using this formula. So it's important that we keep these formulas handy for us. Okay, so for the first one, we have find the exact value of cosine of 5 pi over 4 minus pi over 6, okay? And it's talking about cosine, right? So we're going to be using these formulas, okay? We have the subtraction one, so we're going to be using this one. Okay, first I need to establish what is sine and cosine of these. Okay, so I have the cosine of 5 pi over 4 minus pi over 6. Okay, this is going to be equal to, we have cosine of alpha. So this is alpha and this is beta. So alpha. So we need the cosine of alpha, which is 5 pi over 4. So we look at our pie chart. 5 pi over 4, this is my cosine. That's my sine. Okay, so 5 pi over 4, we have negative square root of 2 over 2, and then negative square root of 2 over 2. And then pi over 6, we have the square root of 3, and then the square root of 3 over 2, and then a half. And that's a 6. Okay, so we have cosine, sine. Okay, so I'm going to use this formula. So cosine of alpha, so I have negative square root of 2 over 2 times the cosine of beta, which is the square root of 3 over 2, right? Plus sine of alpha, so, negative square root of 2 over 2 times the sine of beta, which is a half. Okay, and we're just solving. We're finding the exact value. So we have negative square root of 2 over 2 times times square root of 3 over 2. So this becomes negative square root of 6 over 4. Okay, plus we have negative square root of 2 over 4. Okay, so they have the same denominator, so they're both going to be over 4, but we have negative square root of 6 plus a negative, so just minus square root of 2. Okay? So this is our answer. That's the exact value. Don't worry about completely giving me decimal and all that stuff. This is what we need. Okay? So the next one, we're finding the exact value of cosine of 75. We're not given an alpha and beta, right? So I have to think of two numbers that are going to add up or subtract to be 75. And so I'm going to choose the route of adding, okay? So I have 45 plus 30, okay? I can rewrite that like that. Okay, and you have to pick numbers that are on the unit circle so that you can find its terms. So we're going to have cosine of 45 plus 30. So we're going to be using this top one. So this is alpha, and that's beta. Okay, so remember, we have 45 degrees and 30 degrees. So I need the cosine and sine. So 45 degrees, I have square root of 2 over 2 and square root of 2 over 2. Okay, for 30 degrees, I have square root of 3 over 2 and a half. So I have my cosines and sines now. So for this one, I'm going to have cosine of both multiplied to each other. So I have square root of 2 over 2 times the square root of 3 over 2 And then this time it's going to be subtracting the sign of both. So square root of 2 over 2 times the half. Okay, so I have it plugged into my formula, and now I'm just solving. So this becomes the square root of 6 over 4 minus the square root of 2 over 4. Okay, 2 times 3 gets 6, 2 times 2, 4. Square root of 2 times 1, square root of 2 over 4. Okay, and then they have the same denominator. So I have the square root of 6 minus the square root of 2. Okay, that's it for 1 and 2. Okay, the next one, we're finding the sum and difference of sine. So similar formulas, okay, except last time we had cosine, cosine, sine, sine, and now it's opposite. So we have sine of alpha, cosine of beta, cosine of alpha, sine of beta. So they're just a little bit different. So just use the formulas and you're plugging it in. So we have 135 and 120. I need to find the values of these. So on my handy dandy unit circle, I go to 135, and it's negative square root of 2 over 2, and then square root of 2 over 2. Okay, this is my cosine, that's my sine. Then I have 120, so it's negative half, and then just square root of 3 over 2. Okay, so now I'm plugging it in. I have the plus sign, so I'm going to be using this one. This one's alpha, this one's beta. So I have sine of 135 plus 120. It's going to be equal to, so the sine of alpha, which is 135, is square root of 2 over 2. Cosine beta, so that's negative half. Okay, and we are adding, so we're going to continue adding on this one. Okay, so now we need to find the cosine of alpha and the sine of beta. So cosine of alpha is negative square root of 2 over 2, and the sine of beta is the square root of 3 over 2. Okay, and we're solving. So I have the negative square root of 2 over 4. Okay, and over here I have the negative square root of 6 over 4. So this turns into negative square root of 2 minus the square root of 6 over 4. Okay? So we're just plugging into the formula. Next one, number 4, sum and difference for tangent. So we have another formulas. So for tangent and that. So first thing I need to do, and I'm going to be giving you the tangent so you don't have to find it like you were doing in your last week's sessions. Okay, so we're given our tangents. I just have to plug it into the formula now. So I have the positive one, so I have tan of pi over 6 plus pi over 4. Okay, so I'm going to be using this formula. So tan of alpha, so this is alpha, and that's beta. So the tangent of pi over 6 is 1 over the square root of 3, okay, plus the tangent of beta, which is 1. Okay, then I have 1 minus the tangent of alpha, which is the first one, so 1 over the square root of 3, times the tangent of beta, which is 1. Okay? So when I simplify this, I have 1 over the square root of 3 plus 1 over 1, and then 1 over the square root of 3 times 1 is just itself, so 1 minus 1 over the square root of 3. Okay? And you're looking at this saying, yay, we're done. But are we? Are we done here? No. Okay, because I have fractions. So I need to make these the same. So this is going to be written as, we have 1 over the square root of 3, and I need to make this have the same denominator, so it's going to be the square root of 3 over the square root of 3 over 1 minus, well, now that turns into the square root of 3 over the square root of 3 as well. Okay, and then minus 1 over the square root of 3. Okay, so now I have the square root of 3 over the square root of 3. Keep the denominator the same. Okay, I'll zoom in. Over, and then I have the square root of 3 minus 1. Square root of 3 minus 1. Okay. Oh, I did something wrong. This is supposed to be 1 plus. We don't combine them. I thought that was multiplication. Okay, over the square root of 3. That looks better. Okay, so now what should we do? We're going to do keep, change, flip. So I'm going to keep this one, 1 plus the square root of 3 over the square root of 3 times, and I'm going to flip it, the square root of 3 over the square root of 3 minus 1. Okay, and you can see that these cancel out. So then you're left with 1 plus the square root of 3 over the square root of 3 minus 1. Okay, and you're just going to leave it just like this. Oh, you can't see that. There you go. Okay? Just take it step by step, and if you have any questions, email me. Okay? Last identities we're dealing with is the cofunction ones. So let me zoom back out just a little. Okay, so basically it's sine and cosine are going to be the opposites of each other, and you're inside every parentheses you have pi divided by 2 minus whatever theta is. Okay, so let's look at number 5. So we have right tan of pi over 9 in terms of its cofunction. So tan, right, pi over 9, so we have tan of pi over 9 is equal to our cotangent of pi divided by 2 minus our theta, and theta in this case is pi over 9. Okay? We need to have like denominators, so I'm going to multiply this side by 2 and this side by 9, so I can have like denominators. So I have 9 pi over 18 minus 2 pi over 18. So this becomes cotangent of 9 pi minus 2 pi is 7 pi over 18. Okay? And that's it. They just want you to write it in terms of its cofunction. Okay? So our next one is we need to verify the identity of sine of alpha plus beta, and then sine of alpha minus beta is equal to 2 sine alpha times the cosine of beta. Okay? So what we need to do, we know that sine of alpha plus beta, right? This term is, we had sine of alpha cosine beta. Let's see. And then we had plus cosine alpha sine of beta. Okay, so this one became this. Okay, now I need to do this one. Plus, and then we have sine, right? We had sine alpha cosine beta minus cosine alpha sine of beta. Right, and we need to verify that this is going to equal 2 sine alpha cosine beta. Okay, we need to verify this. So if I just write this all out, right, I have sine alpha cosine beta plus cosine alpha sine of beta plus the sine of alpha cosine beta, and this would be minus the cosine alpha sine of beta. We're going to just combine like terms. So combine okay, so let's look and see what we have. So we have this one, sine alpha cosine beta, and then we have sine alpha cosine beta. They're both positive, right? So this becomes 2 sine alpha cosine beta, okay? And then we have this one, we have a positive, and then we have a negative. So these are cancel. So these cancel, and we're just left with this. So that does equal to sine alpha cosine beta. Okay?